Greetings, hello, and thanks for joining me today. I'm Ralph, EI2KU. This is going to be a very quick look at the tinySA, what it does and why you might want one. If you've got any questions, you can look me up on qrz.com, drop me an email, and if I can, I will help. So, the tinySA is a spectrum analyzer. Now, quite a few of you will probably be familiar with the concept because a lot of rigs nowadays have a pan adapter, which shows the spectrum across the band you're looking at with the content of the signals. And that's really what a spectrum analyzer does. Frequency along the horizontal scale, amplitude along the vertical scale, usually in dBms, so it's a power, measuring power. And here you're looking at a classic of its time anyway, an HP 8560, really nice piece of kit. Very capable, goes from 30 Hertz up to nearly 3 gigahertz. Very sensitive, lots of menu options. And it's still very popular on the second-hand market. If you get a good quality copy, will probably still cost you a couple of £1,000. So a little pricey for most of us hobbyists. So step in the tinySA. This is a spectrum analyzer, albeit very tiny. Screen is 2.8 inches, but it's very capable. It has two frequency inputs, the low input and the high input, as they're called. The low one goes from 100 kilohertz to 350 megahertz, and the high one 240 to 960 megahertz. Though it uses some harmonic tricks to extend the range, so the performance isn't quite so good. It's also pretty sensitive, really. It can go down to almost a minus 100 dBm. The one shortcoming of it, perhaps, is the resolution bandwidth of 2.6 kilohertz, which is a definition of how narrow a signal it can display. And if you think that our SSB signals usually are of that order, 2.5 to 3 kilohertz, then it'll give you some idea. There is, well, by comparison, this bad boy here can go down to a resolution bandwidth of about 1 hertz or something, I think. So big difference. Big difference in price too. The tinySA is getting a slightly bigger brother coming out shortly, I think next month. This one, the tinySA Ultra. Bigger screen, similar sort of frequency coverage, but a resolution bandwidth down to 200 hertz, which is much better. So if you can justify it, I mean, it's a lot more expensive. If your needs can justify that, then go with a bigger one. Otherwise, the tinySA is just perfect. I've been using one for some time. Great piece of kit. What you would use it for, checking signal purity is the main thing, probably. Looking at whether your transmitter has harmonics or whatever. Almost impossible to do it any other way. Searching for local noise sources is very good for that too. If you've got something which is creating shitty signals on your on one of the bands, then you can go looking for it. It does also work as a signal generator. Both the high and the low outputs produce a signal, though the high output is a square wave, so it's full a lot of harmonics. But the low output is a good general purpose signal generator. If you're working on oscillator circuits or something, you know, for whatever project, then you can check the output is how clean it is and so on. And also, I mean, any sort of general home brewing, equipment servicing stuff, and an analyzer like this is almost indispensable. So let's quick look at that. As an example, for those of you not so familiar, if you're looking at a transmitter or oscillator or something which has a kind of a messy output, and you're looking at it on an oscilloscope, then you'll get something like the green trace here, which is a summation of all the different signals. And in reality, it often looks a lot worse than that. It looks a real mess. So, you know, you can't really make any sense out of that, right? Put it onto the tinySA though, and you get a clear picture now of the different signals and their amplitudes. So the left hand time domain, the right hand frequency domain. Hopefully that's clear enough. The other thing is checking for noisy equipment. Now, this is an example from my own shack actually. I have a big LED light for illuminating the workbench, and the red trace here is with it switched off. The yellow trace is with it switched on, and as you can see, it's pretty noisy. I mean, okay, the tinySA is sitting right next to it, but nonetheless, it's very noticeable on the HF bands, certainly the higher bands, when I turn it on. So, you know, I knew there was something noisy, and I found it with the tinySA. So it's really handy for that because it's very portable, obviously. Other things, looking at amplifiers, excuse me, amplifiers and your output. This is a real example I've worked on. The linear amplifier you see on the right is sold from our friends in China as a linear amplifier for the Zygo G90. It comes with all the cables. You just plug it in, you switch it on, and poof, there you go. You're getting nearly 100 watts instead of the 15 out of the G90. They say it's got filters. Actually, it doesn't. I mean, okay, there is a bit of a roll-off higher up, but there are no individual band filters. Not only that, it's not actually that well designed as a linear amplifier. It's not terribly linear. And this picture shows what I measured on its output with a 20-meter signal going in. And as you can see, the harmonics, that first harmonic you're looking at is only about 20 dBs down, which is really not good. I mean, you're looking for should be more than 40, preferably 60. I mean, the Zygo on its own, for example, when you look at that output, I couldn't really measure any harmonics at all on the tinySA. They're that low. So, you know, as another example how without the tinySA, you just couldn't do that. You couldn't really see that properly. But a word of caution, if you're going to be looking for a linear like this, treat it. I think you need to know what you're doing. The other word of caution, perhaps, is that the tinySA's maximum signal input is 10 dBm, which is just 10 milliwatts. So you need to be in our sort of transmitter environment. You've got to be really careful. You don't overload it, because if you fry the input, then it's game over. It's not repairable. So the recommendation would be always have something like a 20 dB attenuator on its input when you're working with this kind of thing. I mean, when I made that measurement, I had a 30 dB coupler and another 40 dBs attenuation, so I'm 60 dBs down. So be careful with that. Other things, you can make nice, you can do phase noise measurements and intermodulation measurements with it. It's got menus that allow you to set it up to do that directly. And there's more information on their wiki that you can have a look at if you want. And there's some good videos on YouTube too. There's a guy called Eric. I'll leave a link in the description to his channel. He's done a series of short videos that show you how and how not to use the tinySA. And they're well worth looking at. If you are going to go out and buy one, beware of the copies. There are copies, clones, spin-offs. A lot of them, maybe not all, I can't say about all, but a lot of them have been unreliable and have performance issues. The authorized seller for us in Europe is Shop. They're in the Netherlands. I use them, great bunch of guys. And for 54 euros, there's no point trying to save 5 or 10 quid by getting it anywhere else. The Ultra, good bit more expensive, so if you can justify that, great. Otherwise, stick with the tinySA. No reason to do anything else. So that's it really. Just a very quick overlook. As I said, if you've got any questions, get in touch. But I'm going to sign out. 73s and good DX. That's at least if I can work out how to turn this off. Why are there never any menus when you need them? Pants. I'll have to edit this now. Yeah, pants. Where is it? There you go. Bye.